We're live, it's working. Woohoo! Okay, so here's what I want to talk about. So we know, in fact, I was just telling you that we use sine, and we use cosine, and we use tangent, right? So if I take a look at my unit circle, and let's write this stuff down. I know that, first of all, the x value is the cosine, right? And I know the y value is the sine, right? We know that. The tangent is the y over the x is the tangent, okay? What I'd like to do is make my circle convenient, okay? I really don't want to go and divide every single time, you know, this divided by this. So what I want to do is figure out what is 1/2. Actually, let's start here. Nope, let's start here. What is square root of 2 over 2 divided by square root of 2 over 2? Hopefully that's easy. What's square root of 2 over 2 or square root over 2? That should be easy. What's the answer? 1. So I'm going to put those, to make it easy, I'm going to put my tangent values on my circle. I'm going to put them out here, okay? So my tangent values for me are in blue, okay? Now I don't care. You guys may or may not use colors, but I'm going to use colors because it makes it easier, okay? So if it's 1 here, it's going to be -1 at 3 pi fourths, right? The tangent value of -3 pi fourths of 3 pi fourths is -1 because I've got square root of 2 over 2 divided by negative square root of 2. And then down at 225 degrees, it's going to be +1 again because you've got the negative divided by the negative, so that's going to be a +1, right, for my tangent values. And then down at 315 degrees, it's going to be a -1 again because I've got the negative divided by the positive, so I've got a -1, okay? Now, let's keep going with this. So I want to get my tangent values on my unit circle so it makes it easy for me, okay? Square root of 3 over 2 divided by 1/2. If you invert and multiply, the 1/2s cancel, and you get just a square root of 3 as the tangent value of 60 degrees, okay? And then over here at 120 degrees, same thing. You got square root of 3 over 2 divided by -1/2 gives me a negative square root of 3. Okay, so I'm just going to put my tangent values. It just makes it easier for me. I'm just trying to make it so if I say, boom, Spencer, tangent of 120, you don't have to divide. You can just look at your circle. Mr. Davies, it's negative square root of 3. See how we're trying to make it easy for you? At 240, we'll have the same thing, but we'll have the negative divided by negative, which is a positive square root of 3 for my tangent value. And then at 300 degrees, we'll have a negative divided by a positive for the 300 degrees, which is going to make just a negative square root of 3, okay? Now, hey, how are you?
Hi, Mr.
Giovanni, how are you?
Is Faith here?
With who?
Faith.
Faith is not here. I'm sorry.
Okay, thank you.
You're welcome. Okay, now I'm going to do a little work because I don't want to mess this up. But if I go to 30 degrees, if I go tangent of 30, and you guys just watch, you don't have to write this down. It's really going to be 1/2 divided by the square root of 3 over 2, okay? Y divided by x. Got it? So if you invert and multiply, that's the same thing as 1/2, flip it, times 2 over the square root of 3, right? The 2's cancel, and you're left with 1 over the square root of 3, which is an okay answer. But remember, we're not really supposed to have a square root in the denominator. Remember that? So we rationalize it. Oops. Square root of 3, square root of 3. And we wind up with this answer, square root of 3 over the square root of 9, which is 3. And that's the answer we want to put on our unit circle. So at 30 degrees, or pi 6, the tangent value is the square root of 3 over 3. Okay? It doesn't show very dark, but that's okay. And then over here at 150 degrees, we'll have the same 30-degree angle, but it's going to be negative because of the negative here, so it's going to be a negative square root of 3 over 3. Okay, these are just convenient because I'd rather just say what's the tangent value, got it, versus trying to figure this out every time. I've got another 30 degrees here, but I've got the negative divided by the negative, so it's just going to be a positive square root of 3 over 3 at 210 degrees, or 7 pi 6. And then the last one I've got is over here. I've got the negative 1/2, which is going to be negative square root of 3 over 3. Okay, so now my tangent values are my unit circle, right? Good. Almost all of them. Now let's go to 0. That's like 0 radians or 0 degrees. We got 0, either 0 radians, 360 degrees, 0 degrees, or 2 pi, right? So again, if tangent's the y over the x, the tangent values at 0 is 0, right? You okay with that? And at pi, the tangent value is 0 over -1, which is just 0, right? Let's put 0 here. But let's take a look at 90. Cookie Monster is going to be very, very upset at 90. What's the problem with 90? Why is Cookie Monster going to be sad? So we're going to put this symbol. It's really what we'd say undefined, but I'll just put this symbol, which is, it's called the empty set, but it really means undefined. There we go. And then, of course, down at 270 degrees, the same problem happens. Cookie Monster's unhappy because he has 1 friend and 0 cookies, and that's just not good. You can't divide any cookies up, okay? So, we've got all our tangent values. Okay, so if I take a look at my notes today, and I wanted to find the tangent of something, I could. But now these are a little tougher, doggone. I'm so sorry. We're going to have to, but we will not do a lot of these, okay? We will not do a lot of these. So, let's go ahead, and today's date is 5/3/21. The objective today is really finding the trig values on the unit circle from the, we call them co-functions, from the co-functions, okay? All right. I'm going to find the trig values on the unit circle from the co-functions, okay? Now, today's going to take a little bit of work, but it doesn't scare me, okay? So you ready? Here we go. Cosecant is the opposite of sine, okay? Because sine of theta is the y over the r. Secant is the cofunction of cosine, because cosine of theta is the x over the r. And cotangent is the cofunction of tangent. So I know tangent of theta is the y over the x, okay? We know that. So if we have to use the unit circle, then we know that the radius, I'll put this in red, we know the radius is 1. That makes it easier, okay? That makes it easier, okay? So then, example 1, cosecant of 30. Well, I know cosecant is r of y, but the r is 1. So it's really going to be trying to find 1 over the y value, okay? Cosecant's the r over the y, but the radius is 1. So cosecant's really 1 over the y. So I go to 30 degrees, and the y value is 1/2, okay? So what I'm going to have is 1 over 1/2, which is just 2. You okay with that? If I just will flip it up, the answer is just 2. Secant. Secant is r over x, but the radius on the unit circle is 1, so it's really 1 over the x value. So let's go to 315, and the x value is square root of 2 over 2. So I'm going to have 1 over the square root of 2 over 2. Well, that's really an ugly answer. I can fix that answer, flip it up, and make it 2 over the square root of 2. Well, that's an ugly answer. So I'm going to try and fix that one. Square root of 2 over square root of 2. It's getting better. I'm going to get 2 square roots of 2 over the square root of 4, which is 2. Now, that's not necessarily an ugly answer. I can cancel my 2's. And there's my answer. Okay, Cotangent of 240. How am I doing? Am I doing okay? Is it making a little sense? This one's a little bit harder. Cotangent. Cotangent is the x over the y, right? All right, 240. X over the y, which is going to be my negative 1/2. Or, that seems kind of complicated. Or, you want to do an easier one? Or, isn't it just 1 over the tangent value? That's easier. So the tangent value at, oh, I'm at 240, hold on, 240, there you go. The tangent value is square root of 3. So let's do 1 over the square root of 3, and of course I have to rationalize that, remember? Multiply by the square root of 3 over square root of 3, and I get square root of 3 over square root of 9, which is 3. Okay, how am I doing? I'm like, I keep doing this 400, should be 400. I'm going to skip to example 2 because these are the same, okay? Just because I'm going to run out of time, okay? So cosecant of 3 pi 4ths. The only difference is we're using radians. Cosecant still 1 over the y value. 3 pi 4ths is there. If it's 1 over the y value, it's 1 over the square root of 2 over 2. Now I did that one, I think. Didn't I do that 1 over the square root of 2 over 2? I did all that work up here, didn't I? I did all that work up here, and the answer turned out to be just the square root of 2. I don't need to do the work again. You guys agree? I already did it, right? Let's just leave it, okay? Secant is 1 over the x value. Okay, let's see. The x value is secant 5 pi 6. And the x value is 1 over, see, the x value is right there. Negative square root of 3 over 2. So if I flip that, what a mess. Flip it, same thing as 2 over negative square root of 3, but that's not right because you can't have a square in the bottom, right? So you have to fix that. Multiply by square root of 3, square root of 3. I wind up with a negative 2 square roots of 3 over, well, that's the square root of 9, which is 3, or negative 3. Whew, it's an ugly answer. Okay, these are the same, okay? You guys okay with that? These are basically the same, okay? It's worth looking at cosecant of pi, though. Is that the one I want to look at? Yes. Cosecant of pi, 1 over the y value. I do want to do d because...
Oh, yeah, never mind. You just said it. I was going to do d.
Huh?
You just said we're going to do d, but I was going to ask. That's why.
Let's do d. That was a good question. So the problem with d, and hopefully you guys can see it, is what's the y value?
Oh, wait, there's 2.
Did I make 2 d's?
D, C, D, E. Yeah.
Oh, wow.
Can you do the negative one, too?
I can.
Only because, yeah.
Okay. Cosecant, pi, the y value is 0. Cookie Monster sad. You guys agree? Undefined. Don't write empty set. It really is just undefined. If you wrote the empty set, I wouldn't mark it wrong, okay? All right, let's do D. Cotangent. So I think the easiest way to do it is 1 over the tangent value, because then there's only one number to deal with. If you do it as the x over the y, then you've got 2 fractions to deal with, okay? This will work, but this is faster because there's only one number to deal with, okay? So I go to negative pi 6. So it's a rotation. Watch this, Chloe. Here's pi 6, okay? Think about this. I rotate up to pi 6. It's an angle rotation. So if I rotate down, it's this angle here. Okay? It's this angle here. And it's almost worth putting that in my negative pi 6, so I know that's the same thing on my circle. So what am I looking for? The cotangent, right? Which is the opposite of tangent. So I'm going to have either 1 over this number or this number over this number. Which way, do you want to do 1 over this number, or do you want to do this number over this number? Tangent, let's just do the tangent. Yeah, let's just do the tangent. So it's going to be 1 over negative square root of 3 over 3, okay, because that's the tangent value there. That flips up to 3 over negative square root of 3, but of course that's a pretty ugly number, right? Can't do that. Have to fix it. Can't have a square root at the bottom. Square root of 3, square root of 3. Let's see what I get. I'm going to get 3 square root of 3 over square root of 9, but square root of 9 is 3. My 3's cancel, and I just get negative square root of 3. How's that? Okay, these are kind of a pain, and again, I'm sorry, no one ever uses this. They use sine, cosines, and tangents, okay? Now, calculator, okay? Now, calculator is not as easy as you think, okay? But once I show you, you'll get it. Now, secant is not on your calculator. You have to have a really fancy calculator to get secant on your calculator. Secant, I don't care what you do, you will not have a secant button on your calculator, okay? So what do? Well, it's easy. It's just going to be 1 over what? Secant's 1 over what? Sine, cosine, or tangent? 1 over what? So it's just 1 over cosine of 58. You don't need a secant button in your calculator because you're just going to go, mode, check my mode, mode. Before I mess up, why did I check my mode? I'm in radian mode. I'm going to get the wrong answer. You guys agree? It says 58 degrees, so mode, quit, and then I can go 1 divided by cosine 58, and I get an answer of about 1.887, okay? Okay.
You have sold box?
I do have Zoe Boggs.
Okay.
Will you go give
Yeah.
her to her? I'm in the middle of teaching, big guy.
Sorry.
Okay, no, you should be sorry. You're on candy camera. Wave to the camera, because you're on the camera. There you go. Okay.
Where?
Yeah, what about B? Well, you don't have a cotangent button on your calculator, but you have a tangent button. So I'm going to go 1 over the tangent of 1.2, but, mode, right? You agree? Mode, clear. And I'm going to go my mode back to radians, enter, quit. 1 divided by tangent of 1.2, and I have about 0.388, 888, I guess, 888, okay. Reference angle, real quick. We've talked about that before, and I'm just going to do a real quick review of it. Reference angle, if I draw a 130 degree rotation, it's about there. But you can't draw a right triangle. You can't draw a right triangle from 130 degrees. So we create a right triangle along the x-axis. Always along the x-axis. Always along the x-axis. Always along the x-axis, so that my angle is 50 degrees. That's my reference angle, okay? And last but not least, number 5. Number 5 is like a warm-up. It's a great problem. I like this problem. Let's see. If quadrant theta is in quadrant 2, 1, 2, 3, 4, right? Tangent is a y value over an x value, okay? So I have a y value of -3 and an x value of 4. So that means, in a sense, I have a coordinate of 4, -3. I'll let you think about what I just wrote, right? So this is not on a unit circle because it doesn't have a radius of 1. So this triangle can be found, x, it's a y value over an x value, so I know my y value is -3 and my x value is 4. So if I go this doesn't make sense. I can't get into quadrant 2. If it's really 4, negative 3, it puts me in quadrant 4. But fractions can still be negative that way. What? Well, isn't these two numbers the same? Aren't those two numbers the same? So it really means the point I want is 1, 2, 3, 4. 1, 2, 3. And I get a triangle right there. So I know my x value is negative 4. My y value is positive 3. What I don't know is my radius, right? I don't know my radius. So if I had to find my radius, I'm going to go x squared plus y squared equals r squared. I'm going to go, giving you a lot today, aren't I? Negative 4 squared, because that's x squared, plus y squared, which is 3 squared, equals r squared. Spencer's getting it. It's going to be 5, isn't it? 16 plus 9, which is 25, which r is 5, okay? I am almost done, I promise. That's why a longer periods sometimes are convenient, okay? So here's what else I'm going to add to this. R is equal to 5. Now I'm going to circle that, because that's the information I need. Okay, here comes the easy part. You ready for the easy part? Okay, sine of theta is the y over the r. We know that. We learned that last week. I also went through it on our warm-up, right? So the y value, 3/5. Sine, cosine of theta is the x over the r. All right, well, now I know the x is negative 4 over 5. Tangent, I already know tangent. I did tangent, right? Tangent, they gave me tangent. Tangent's here. I know tangent. So then let's do instead cosecant. Well, cosecant is the reciprocal, the cofunction of sine. So it's just going to be 5/3. Opposite of that, it's going to be just 5 over 3. And secant of theta is just the reciprocal of cosine. And if cosine is negative 4/5, then secant is going to be 5 over negative 4. And then finally, cotangent's really easy because it's the reciprocal of tangent, but they gave us tangent, right? So cotangent is just going to be 4 over negative 3. Okay. That was a lot of teaching, you guys. Sorry, that was an awful lot of information.